That means that 450 nanometers is less than the threshold frequency, more than the threshold frequency.
It is wavelength. So you need to convert it into frequency. Okay,
Yeah.
you will write it like this, that the blue. Okay, no, sorry. You will write it like that. The lambda is inversely proportional to frequency. So this will be less frequency. This is F1, this is F2. So F1 is less than F2. So frequency of this is less than the threshold frequency. So that's why it will not emit electron. And this frequency is greater than the threshold frequency. So that's why it will emit electron. Question number 3.
No, but you need to explain the observation. So the color.
Color is not given to us.
I don't know. Go to the box scheme at the bottom of the book.
Okay, if light of a wavelength is given to you. Okay, so and also a wavelength of the visible light is not given to you. So how you will remember all that wavelength for red, violet?
The wavelength, the frequency is constant. Oh wait, the frequency is.
Not the frequency is constant. This you just explain this. Explain this observation. You just need to explain the observation.
Okay, fine.
Yeah. No, not go toward the red light, the wavelength, because the teacher know that remember all these wavelength is difficult for students. So you just clear the concept of the checker.
Yeah, you're right.
And also, when you answer any question, then explain it like as you are explaining it to a child. Okay, so teacher will be impressed from your this.
Yeah, step by step, bullet points.
Yeah, step by step. There, this is this, this is this, this is just like that. And also check the marks. If it is 1 mark, then answer in few lines. Okay, instead of everything, because then the time will. You should make the time arrangement in your paper.
Yeah.
Function of a certain metal plate is etna. One function is given to you. The threshold frequency of incident radiation for this metal. We need to find threshold frequency. The maximum kinetic energy of photoelectron emitted from this plate when light of wavelength etna is directed at the metal surface. Threshold frequency energy is given to you. Okay, this is the work function. Okay, not the incident light. So that will be your threshold frequency. If it is the incident light energy, then that will be your simple frequency, not the threshold frequency. Got it?
Yeah.
So you can find the threshold frequency from this formula. H will be.
Oh yeah. You're right. Just divide the energy Planck constant, then you get the answer.
The maximum kinetic energy of the photoelectron emitted from this plate when light of wavelength is okay. Wavelength of light is given to you. So as we know that V is equal to F lambda. So lambda will be equal to C is 3 times 10 to the power 8. As electromagnetic speed of electromagnetic radiation will always be the speed of light. Okay, wavelength is 520 times 10 to the power minus 9. So from this you will get frequency. Yes, frequency. And you need to find the maximum kinetic energy. Okay, so E is equal to HF. Okay.
E equals half mv squared.
No.
Oh, sorry. E.
This is the work function, and this. So kinetic energy will be equal to.
Yeah. Look, I wrote it.
E minus E. Yes. Good. Okay, light of wavelength etna is directed at the metal surface of 0.1 electrons are emitted from the plate with the maximum kinetic energy is given to you. You need to find the energy of the photon of this wavelength. Okay, calculate.
Okay, E equals. Wait. Isn't it just this?
Don't know. Think about this. Then answer me. I will not help you in this question. As I explained 3 questions, and this is too easy.
Oh my God.
Sorry, you are in the bad condition, as this is the ending time, but you need to solve this question.
Okay, I'm doing it. I want to play PUBG. I don't want to.
No, actually, PUBG wasted 2 hours in 24 hours. In one day, that wasted my 2 hours. So that's why I uninstalled that app.
Oh my god!
Yeah, I uninstalled it.
It's so addicting.
Yeah, it is so addicting and it is so time. That's consume lots of time. So that's why. Actually, I normally before Ramadan I go toward the bed at 12 p.m. Okay, at 12 a.m. But
Yeah.
I slept after. Then I started the PUBG. Then I slept at mostly at 2 p.m. or 3 p.m. So that game wasted 2 or 3 hours. That's why I uninstalled that.
Oh my god.
But
Uninstall.
but I will install it later on after your exam,
Oh my god.
and we'll play a game with you.
Yeah. It's hard. This is hard.
Okay, it's hard. Okay.
Okay, wait, let me try it. E equals work function plus KE
mhm.
equals.
You need to find the energy of photon. Okay. Actually, the energy of photon, okay, kinetic energy is given to us, and we need to find the energy of photon, and light of wavelength is also given to us. So you need to find it by using this formula.
Oh, so equals hc over lambda equals. Let me check the mock scheme. Questions for a 3.1 times 10 to the power minus 19. Okay, you don't need to write it. I understand.
Okay, so this is the energy of photon. The work function.
E minus 1.5 times power of minus 19.
Yes. The threshold frequency of the electromagnetic radiation incident on this metal.
Easy. Work function divided by h equals threshold frequency.
Yes, work function divided by h. Good. Okay, a vacuum cell is connected to a microammeter. Explain the following observation. When the cathode was illuminated with blue light of low intensity, the micrometer showed a non-zero reading.
Oh my god, that's so hard.
The micrometer reading was 0. Okay. Actually, for this you need to remember that band. Radio wave, infrared, visible, ultraviolet, gamma, X-rays, cosmic rays. Invisible we have with Geo. You need to remember this. With violet, and this is red. Okay, these are opposite. Okay, it is opposite like this. If you move towards this, then X-rays. When you hear this word X-rays, then one thing come in my mind that this is very intense light. Okay, so remember from this X-rays. So the frequency will increase. If you move like this, frequency will increase. But here the situation is opposite. When you move like this, then the frequency will get decreased. I remember it like this. I don't know how you remember all these bands, but I remember.
Yeah, I get it. I get it.
Okay, so the frequency will get decreased. So here we have red light and blue light. So blue light, this is the blue light, and this is the red light. So red light frequency is less. Okay, so this frequency is less than threshold frequency. So that's why reading is 0. And blue light frequency is greater than the red frequency, and it is also greater than the threshold.
Oh.
So that's why we get non-zero. Okay, remember this like this: RIV UXGC. I remember it like this, simple: RIV UXGC. And this is
I know this one easy. Video is easy to remember.
Yeah, it is easy, and most students remember this, but most of the students don't know about this, because sometimes this question come like this: ultraviolet radiation fall on metal, or sometimes come that gamma radiation, yeah, X-rays fall on this. So gamma's radiation have more frequency than the ultraviolet, and X-rays have more frequency than the ultraviolet. So remember it like the RIVUFGC.
What is this?
This is cosmic rays. Actually, nowadays scientists invented this cosmic rays. Okay.
I think this is wrong. This is X. This is G. Look. This is X. This is G.
I remember it too long ago. No, it will be red. Okay, wait, I will check it. Electromagnetic.
No, I can't wait to eat. I just want to eat food.
You just want to?
Eat.
RMIV UGX UXG. RMIUXG. XG, yes. RMIUXG. GC. There is also a cosmic ray. Okay, so next question. If a Q photocell is connected to a microammeter, when light is directed at the photocell, the microammeter reads 0.25 microampere. Calculate the number of photoelectrons emitted per second by the photocathode of the photocell. It's easy. Explain why the micrometer is double if the intensity of that source is double. Okay, I explained it yesterday.
Wait, let me do it. Let me do A, part A.
Number of photoelectrons.
So 0.25 times 10 to the power minus 9. Minus 6 or minus 9?
This is microampere. Microampere. Minus 6.
So minus 6.
That is nanoampere, okay?
What is the charge of 1 electron?
Charge on 1 electron is 1.6 times 10 power minus 19.
Is this the answer? 0.25 times 10 to the minus 6 divided by 1.6 times 10 to the minus 19 equals number of electrons per second.
Yes, that should be the number of electrons per second, and that should be equal to, if the answer is 5.6. So your number, if the answer is 5.6, then your answer will be number of electrons is equal to 5.6. Is it right?
What's the answer for this?
No, if you calculate all these numbers, okay, and let's say your answer is 5.6. Let's say.
Wait, I got the mark scheme.
No, don't go toward the mark scheme. This is a simple question. If the answer is in the decimal number 5.6 or 5.8, then what you will write? You will write that the number of electrons is equal to 5.6.
Round it up, 6 electrons.
Okay, so you will write that it is 6 electrons. 6 electrons is like 5 complete electrons and 1 is the half, 60%.
Wait, put this in the calculator. Write this in the calculator. 0.35.
Actually, I don't have a calculator, but if you have, you can. Okay, now.
Okay, let me get my calculator.
Okay, I have a calculator. Okay, I will do it. You have Rosa, so that's why I will do everything.
Oh, okay, fine. I got the calculator.
Okay, 0.25 times 10 to the power minus 6 divided by 1.6 times 10 to the power minus 19. What is your answer?
1.5625 times 10 to the power 12.
12, 10 to the power 12. Times 10 to the power 12?
Yeah.
Okay. So you will.
No, sorry. I don't know. What is the charge of 1 electron?
1.6 times 10 to the power minus 19.
What exercise is this? 3.1 or 3.2? Let me check the mark scheme. What exercise is this?
This is, I think, chapter 3.
3. Go up. Just go up.
3.2.
Okay.
Question
3.2.
Question 2.
3.2 question 2a is 1.6 times 10 to the power of 12. So we're right. Right.
So these are the number of electrons.
That's right.
Next question. Explain why the microammeter
reading is doubled if the intensity is doubled. So I equals Ka squared.
Okay. We'll just explain it. Actually, Einstein tell us about this.
Oh yeah, let me just remove that.
No, he said that the light particle which incident on the metal surface, that is known as the photon. Okay, and energy of photon is equal to hf. Okay, and 1 electron will absorb complete 1 photon. Okay, 1 photon come, then 1 electron will get absorbed. If 2 photons come, then 2 electrons will get absorbed. So if you increase the number of photons, it means if you increase the intensity, then the number of electron ejecting will get increased. If the frequency is greater than the threshold frequency.
But the kinetic energy does not change. The kinetic energy is constant.
No, kinetic energy depends on the frequency of the incident photon. If the frequency is high, kinetic energy.
If frequency is same, but the intensity is
if frequency is same, then the kinetic energy will remain same. Good.
Yeah.
Good.
So important. That's an important concept.
Important. Yeah. So if photon is coming, okay, like this 5 photon is coming, so it will interact with 5 electrons, okay, and it will eject 5 electrons. Okay, so if you double the intensity, like 10 electrons, then it will eject double electron. So if double electron eject, then double electron will move toward the anode, and as we know that when electrons start motion, then that is not net current. So double current will you will feel double current in the see double current in the emitter. Got it?
Yeah.
Yes, that is the interesting concept. You should remember this.
I will remember it. I will remember it.
Okay, question number 3.
Okay.
A narrow beam of light wavelength is given to you, and a power is given to you. Is directed at the photocathode of a. Okay, what is the kinetic to which read 0.4 microammeter? Okay. Calculate the energy of single light photon of this wavelength. Single energy is equal to HF. Okay, yeah, this will be a single energy. Yes. The number of photon incident on the photocathode per second.
That's easy.
How you will find it?
E equals QV divided by the number charge of one electron. Then you find it.
The number of photons. You need to find n number of photons. That either 6 photon will fall on metal, either 7 photon, either 8 photon. This will be the energy of one.
Look, P equals IV, so V equals P over I. So E equals QP over I.
Actually, this is the current which you read after the photoelectric effect.
Oh.
No, you should be careful over here.
I know, but the number of photons incident on the photocathode will be proportional to the number of current.
That is the frequency.
I don't know.
Okay, wait. Power is given to you. Question is per second. P is equal to W divided by T. It means energy of the light which fall on the metal is this.
Oh.
Okay, so this is the energy which fall on metal. And the energy of one photon is this. So it means this energy is equal to the n times the number of photons.
You divide it. I get it.
Okay, so you will divide it by this, question number 1. Actually, this question will always be based on this question. You should use this part. Okay, this is just like this question will be based on this. Okay, some concepts of this part will always be used in this question. So you should keep in mind this question. So you will get the answer of. You will get the help. You will get some sort of help in finding the answer of this part.
Oh, and the answer for C will be the same as the answer for B because the number of photons incident on the electron is proportional.
The number of electrons.
2 photons absorbed, 2 electrons emitted. 3 photons absorbed, 3 electrons emitted.
Actually, we can find it from this.
This is hard.
Actually, the number of electrons emitted per second from the cathode. So current is given to you.
Yeah.
So 1 second and charge 0.4 times 10 to the power minus 6 divided by charge is 1.6 times 10 to the power minus 19.
Yeah, that's right. And
is that equal to the part 2 answer?
No, it's not.
Then what is the reason behind this?
Yeah, that's why I was confused. Do you understand what I'm saying?
Yes, yes, I got it. Actually,
wait.
In this part, you will add one more point.
What point?
I am telling you. Wait.
What's the answer for question C?
That is 2.5 times 10 to the power 12.
Yeah, that's right in the box.
Yes. Okay, so it is not equal to the number of photons incident on the photocathode per second, and we discussed that in question number 2, part B, that if it depends on the number of photons, if 4 photons fall on the metal, okay, then it will eject 4 electrons. Okay, but here we find the number of...
the time interval is different.
It is same.
No, but realistically, if 2 photons are incident on the photocathode, 2 electrons will be emitted, but maybe over a greater time. For example, 2 electrons will be emitted over 10 seconds time. So 2 electrons incident in 1 second, but then 2 electrons will be emitted in 10 seconds. The timing will be different. The rate will not be equal.
No. I think the answer is, the concept behind this is, as we studied that, we have a conduction band and we have valence band. Okay?
Oh.
So, intensity will get double if photon is absorbed by conduction band electron. Okay, if photon come like this and he excites this electron, then this electron will get lots of energy. Okay, so I think that due to so this electron will come toward the conduction band. So I think this is the reason behind this. It will get doubled if all electron is in the conduction band. If photon is absorbed by conduction band electron, and here the photon is not absorbed by conduction band electron.
Oh, it's in the way. Oh, that makes sense. Their positions will be different of the electrons.
Yeah.
I was right. I was right. I said the rate will be different. That thing.
Okay. Check the mock scheme.
The mock scheme doesn't give an answer for the explanation questions.
What about the part B? What the?
Yeah, the mock scheme only gives answer for question 3.
Okay, wait. I am checking that how much the number of photon will be over here. Energy is this much divided by part A. Part A energy is hc by lambda, so 6.63 times 10 to the power minus 34, and 3 times 10 to the power 8 divided by 590 times 10 to the power minus 9.
What is Planck's constant? 6.6 times 10 to the power of what? Minus 34.
34, yes. So energy is this much. 7 times 10 to the power minus 19. Check the mark scheme. Is it right?
For what?
For part A.
Part A, the answer is 3.4 times 10 to the power minus 19.
Yes,
right.
that is right. Okay. So the number of photons, so that will be 0.5 times 10 to the power minus 3 divided by answer. That is 1.48 times 10 to the power 15.
Yeah.
Okay,
That's
so
right.
so some photon is absorbed by valence band electron. Okay, so that's why we get a less number of electrons over here.
But like, even if it's absorbed by the valence band, wouldn't it be emitted still?
It will not be emitted, as the equation said that it will jump toward the conduction band and will wait for the next photon.
Oh, you're right.
So one electron, if that is present in the valence band, that will require 2 photons, okay, one after the another.
So when the electron jumps to the valence band, I mean, when the electron jumps from the valence to the conduction band, is that excitation or is that something different?
That is the excitation. But if that photon energy is less than the forbidden gap, which is present in between valence band and conduction band, then the electron will be unable to excite to the conduction band, and that photon will not be absorbed. Okay.
Yeah, but then how does de-excitation occur?
Then de-excitation will instantly occur. Okay, and that will occur like this, and it will emit energy.
Also, if the second photon coming will be less than the work function, it will go back down. Oh my god,
Yes,
that's
yes,
so
yes.
much.
It will go back down. Actually, if this is the atom, okay, this is the nucleus, and this is the electron. So if electron come over here, okay, so it will, if the kinetic energy is high, if this electron kinetic energy is high, so it will come and it will knock out this electron. Okay, but if it comes slowly, okay, if it comes slowly, then it will be unable to knock this electron. It will come like this, and it will move away. It will flow like this. Okay, not this electron will not absorb. This electron will not hit this electron because the kinetic energy of this electron is low, is less.
Yeah.
Okay. Next question. Use figure 3 to estimate the threshold frequency work function. Frequency is given to that is 4. Is it 4?
Huh?
Threshold frequency. You need to find the threshold frequency and work function.
Yeah, it's 4.
Okay, 4 hertz. Is it 4
The
hertz?
work function will be what?
That is HF.
Oh yeah.
HF node, your threshold. That will be 4, okay, times 4. Think about it. Is it 4?
Wait, you're tricking me. Then why are you telling me? You're tricking me.
Yeah, actually, I don't want to do such type of silly mistake in your exam.
Oh yeah, that's the worst possible scenario.
Yeah.
Okay, wait. Threshold frequency. Let me check. Is it? Yeah, that should be. Let me check the mark scheme though.
Oh, that will be 4 times 10 to the power 14 hertz.
Oh. Oh my god.
That should be good 4 times 10 to the power 14.
Yeah, that's I checked the mock scheme and that's right. We're going to make silly mistakes. We need to be careful, okay?
Yeah, you should be careful. And your teacher?
Okay, next question I already completed. Let's go next page. I've done question 3 already. I mean, I've done this.
Okay, you're done. Good. Okay, so then ionization, you know what is mean by ionization. Okay, if the slow moving electron come and it will hit this electron, then that slow moving electron will not be absorbed by this electron. Okay, because the energy is less. Okay, so that if it is slow moving electron means less kinetic energy. So it means that that electron is unable, that kinetic energy is unable to excite this electron. So that's why it will not be absorbed. Okay, but in this case, it is absorbed. This is ionization. Okay, got it?
More energy is required for an electron to be ionized than
more kinetic energy, more fast electron is required to hit the electron. Fast electron is required to hit the electron. Okay, got it?
Yeah.
Okay. Okay. Then there is electron volt, and you should remember this, that the electron volt is the unit of the energy, not the voltage. Okay. Mostly students did do mistake in such like that electron volt is the unit of energy.
I know. I'm not dumb.
Okay, good. Actually, most students get that electron volt. That is the unit of volt. But it is the unit of energy. And 1 electron volt is equal to 1.6 times 10 to the power minus 19 joules. Got it?
Yeah.
Excitation by collision. Read this question. Read all these thingy. Okay. One difference and one similarity between ionization and excitation.
Skip this.
Okay. If you said that skip this, okay, you will go to, but just give me the answer of this question.
Okay, fine. Explain why a gas atom cannot absorb energy from a slow moving electron that collides with. That's hard. Oh, because if the electron is too slow, then it won't. Wait. Because emission will occur. Emission spectrum and absorption spectrum. Is that what it's talking about?
That occur when ionization, de-excitation or excitation occur. But here there is, I think, no excitation, de-excitation. Why? Because it cannot absorb energy. If the atom cannot absorb energy, then how excitation and de-excitation will occur?
Okay, can I go back? I want to read the text, please.
No, I told you the answer of this.
Please. Okay, wait, let me read it.
I tell you the reason of this.
No, you didn't. I didn't hear.
You didn't hear that if a slow moving electron.
I don't remember.
If a slow moving electron come and hit the electron, then what will happen?
A photon will be released.
Slow moving means less kinetic energy. So if the kinetic energy is less, okay, and if it fall on this electron, okay, then it means that energy is that energy is not too much to excite this electron toward this shell. That is less than the energy difference of these two shells.
Yeah.
That's why electron will remain in this orbit. It will not absorb the energy of this electron.
What is absorption?
Absorption is simple. That if this electron strike this hit this electron, okay, then this electron transform energy to this electron. So you can say that this electron is absorbing energy from the first electron.
Oh. This is. So wait. This electron comes to this electron, and then I didn't hear. Can you repeat it?
Actually, this electron will give energy to this electron, and this electron will go out like this, and this electron will jump toward the outer shells. It will come over here.
That's excitation.
That is excitation, yes. But if the electron is slow moving electron, then it means that this electron is providing energy, and that energy is up to this. So that's why this electron will not absorb that energy, and it will remain in this orbit, because this electron is unable to jump to this orbit. As electron.
Why? Is it because the kinetic energy of the colliding electron is too less?
Yeah, that is too less.
That's common sense. What type of question is this?
The question is simple.
This is a silly question. I don't like it.
Actually, why a gas atom cannot absorb energy from the slow moving electron? Slow moving electron means less kinetic energy. That electron which have less kinetic energy, and that energy is insufficient for the electron to do excitation through that energy.
Yeah.
Actually, this is the nucleus. In the first shell we have 2 electrons. In the third shell we have 8 electrons, and this shell is the complete shell. And the fourth electron we have vacancy. So if electron come and hit this electron, so this electron will need energy to jump to this shell, not this shell, because this shell is full, no vacancy. Here we have 8 vacancies.
Where? Oh yeah, I know.
Then this much energy should be provided by this electron to do excitation in this atom.
Oh. So the electron must have the kinetic energy equal to, if this is E2 and this is E1, E2 minus E1 equals kinetic energy of electron.
And it should be greater than, it is not necessary that it will be equal to the kinetic energy of that electron.
It's greater than or equal to.
Yeah, and it should be greater because this electron also want to not come in this atom. This atom also want to leave this atom.